Hello there, welcome to CXC Math TV. Today we will be looking at mutually exclusive and exhaustive events. Yes. So now the first thing we want to ask ourselves is, what are these exclusive and exhaustive events, right? It sounds pretty tiring. So we'll start with exhaustive events. What are exhaustive events? Now, exhaustive events are if two events E and F are such that the probability of E union F is equal to the sample space S, then the probability of E union F is 1. Now, if the probability of E union F is 1, then we say that the events E and F are said to be exhaustive. That's all it means, exhaustive. So the union of two sets give us the entire sample space, and the entire sample space, therefore the probability of the union is 1. When the probability of the union is 1, this is exhaustive events. So let's look at an example right here. Alright, so let S be the numbers on a dice, and let A be odd numbers on the dice, and B be even numbers on the dice. And so the set S, the sample space, is going to be the numbers 1, 2, 3, 4, 5, and 6. That's going to be the sample space. Now, A is going to be the odd numbers, and so A is going to be 1, 3, and 5, and B are the even numbers, which is going to be 2, 4, and 6. So A union B is what? 1, 2, 3, 4, 5, and 6, which is what? The sample space. So look at it. A and B are exhaustive because the probability of A union B would just be 1. So if you look at it on the Venn diagram given right here, we can see all the elements of A union B are within the sample space, and because they're within the sample space, there's nothing on the outside of A or B, then the probability of A union B is 1, and so we said that A and B are exhaustive events. Alright, now after exhaustive events, the next one to look at are exclusive events. Now what are these exclusive events? Now two events E and F are mutually exclusive if it is impossible for both of them to occur simultaneously. In that case, the probability of E intersect F is 0 because we're saying that they cannot occur at the same time. And so the probability of E union F is just going to be the probability of E plus the probability of F. Beautiful. Alright, so all we need to remember is that for exclusive events, they cannot occur at the same time, and so their intersection is 0. The probability of the intersection of two events that are exclusive are 0. That's mutually exclusive. Let's have a look at an example here. Let A represent odd numbers less than 10, and B represents even numbers less than 10. So A would be the set 1, 3, 5, 7, 9, and B would be the set 2, 4, 6, 8. So A intersect B is a null set, and so the probability of A intersect B is 0. So look at that. If you're to use the union law, the probability of A union B is then going to be equal to the probability of A plus the probability of B minus the intersection. But the intersection is 0. And so A and B are said to be exclusive events since the intersection is 0, and so the probability of A union B is just the probability of A plus the probability of B. And so if you're to just draw a Venn diagram to represent it, you realize that there's no intersection. When there's no intersection, we say that these are mutually exclusive events. It is that nice. Now finally, there's one more topic or subtopic that we need to look at, which is independent events. Now two events are said to be independent if their intersection, the probability of their intersection, is equal to the product of the two probability of the events occurring. That is, E and F are independent if the probability of E intersect F is equal to the probability of E times the probability of F. That's all you need to remember for independent events. So let us take a look at an example of independent events. So look at this. Let's say A and B are such that the probability of A is 3/4 and the probability of B is a half and the probability of A intersect B is 3/8. And a question might say determine if A and B are independent events. Now the probability of A intersect B is 3/8, we know that. And the probability of A times the probability of B would be the 3/4 times a half. But that works out to be 3/8. So in a case like this, we'd say hence A and B are independent events since the probability of A intersect B is the probability of A times the probability of B. Now that we've learned the laws for what happens when events are exclusive, independent, and exhaustive, let's look at some questions right here now. So we are going to take a look at these 3 questions right here. So let's look at the first one. It says if x and y are independent events and the probability of x is 0.4 and the probability of y is 0.5, find the probability of x union y. Now what do we remember about independent events? If x and y are independent events, then we know that the probability of x intersect y is equal to the probability of x times the probability of y. That is going to be 0.4 times 0.5. That is giving us 0.2. Ah, that's nice. So now that we know that the probability of x intersect y is 0.2, then we know that the probability of x union y is equal to the probability of x plus the probability of y minus the probability of x intersect y. That is using, of course, the union law. So that is 0.4 plus 0.5 minus 0.2, which is 0.7. So the probability of A union B is 0.7. It is that easy. Nice. Let's have a look at question 2. Events A and B are such that the probability of A is 0.421 and the probability of B is 0.34. If A and B are independent events, determine the probability of A intersect B complement and the probability of A complement intersect B complement. Now again, if the probability of A intersect B, that's going to be the probability of A times the probability of B because A and B are independent events. Now the probability of A intersect B is going to be, we'll multiply 0.421 times 0.34 and we'll get 0.14314. Now we need to go back to the other law that we learned in probability, that the probability of A is equal to the probability of A intersect B plus the probability of A intersect B complement. And so the probability of A intersect B complement, if you transpose the formula, you get the probability of A minus the probability of A intersect B. So that's going to be 0.421 minus the intersection we just found of 0.141314. We put that in the calculator and we get 0.27786. And so that is the probability of A intersect B complement. Alright, so we can write that down that the probability of A intersect B complement is 0.27786. Beautiful. And in order to do that, we had to use up the fact that they told us A and B are independent events. Now let's have a look at part 2. We need to now find the probability of A complement intersect B complement. Now, the probability of A complement intersect B complement, that's difficult to find, but using De Morgan's law, that is the probability of A union B complement. Now the probability of A union B complement is equal to 1 minus the probability of A union B. That's using the complement law. And so now we know the probability of A union B, right? Because we know the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. So we know the probability of A is 0.421 plus the probability of B, which is 0.34, minus the intersection. We put that in our calculator and we get 0.619686. And so the probability of A complement intersect B complement, which we know is 1 minus the probability of A union B, that is now 1 minus 0.619686, and that works out to be 0.380314. Beautiful. So if a Venn diagram helps you to do this question, please construct your Venn diagram to look at A complement intersect B complement. Now the third question says, let A and B be even such that the probability of A is 0.3, the probability of A union B is 0.5, and the probability of B is Q. Find the value of Q if A and B are mutually exclusive, and if A and B are independent. Now if A and B are mutually exclusive, then we know that the probability of A union B is just the probability of A plus the probability of B. That's because the intersection would have to be 0. Nice. And so we can just say that 0.5, which is A union B, is the probability of A, which is 0.3, plus the probability of B, which is Q. Making Q the subject, Q is 0.2. Nice. So that would be the value of Q if A and B are mutually exclusive. That's 0.2. Now what if A and B are independent? Now if A and B are independent, then we know that the probability of A intersect B is equal to the probability of A times the probability of B. And so that would mean that using the union law, the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. But the probability of A intersect B is the probability of A times the probability of B, since A and B are independent. So now we can input all of those into the formula, and so the probability of A union B is 0.5. That's equal to the probability of A, 0.3, plus the probability of B, which is Q, minus the probability of A times the probability of B, that is going to be 0.3 times Q. So now bring all the Q's on one side. Q minus 0.3Q, that's 0.7Q. And 0.5 minus 0.3 is 0.2. And so 0.2 is equal to 0.7Q. And so we divide both sides by 0.7. And so Q works out to be 2 over 7. So if A and B are independent, then the value of Q is 2 out of 7. It is that easy. Nice. So those were some exam style questions there. So in summary, we just need to remember if two events E and F are such that the probability of E union F is equal to the sample space, then the probability of E union F is 1, and then events E and F are said to be exhaustive. Now, if two events E and F are mutually exclusive, then that means that the probability of E intersect F is 0, because mutually exclusive mean both of them cannot occur at the same time. It's impossible. And finally, two events E and F are independent if the probability of E intersect F is equal to the probability of E times the probability of F. Alright, and so that concludes the video for today. So stay tuned to CXC Math TV. Alright, so see you next time, and make sure to have a blessed day.